Hello everybody, this is Carmichael the Cat, and welcome to your 22nd Lua tutorial. This is the last tutorial in the main series for our Lua tutorials, and after this we're going on to the C library. So this is just a tutorial to clean things up, go over a few functions we haven't gone over, and just tie up any loose ends. So let's get started. So the first function we're going to go over is called assert, and you're probably familiar with assert if you're familiar with any other programming language, but just in case you're not, what assert does in Lua is it accepts two arguments, and if the first argument is false, then it will return the second argument as an error message, and the second argument is a string. So to show what you'd really use assert for, let's create a function. Oh, we don't want it to be anonymous. Create a function called f, and let's just make it return false. And end. So then we'll run f in assert for the first parameter, and that will return false, so the first argument is false. And then in the string we'll just say error running function. And if we save this and run it, the io.read doesn't get called because there's an error, but I'll just run this a few times. You can see, oh, I accidentally tried to rename it. You can see on the top line, maybe, it says error running function, and then the window will immediately close. But if we change this to true, and save it, then either nothing will happen, yeah, nothing happens. So it just acts like a normal run of the function if the function runs properly, but if there's an error in the function and it returns false, then it allows you to just kind of get the error better than if you just ran the function on its own. So the next function is called error, and this is a very simple function. It takes two parameters, one is optional. The first is an error message, so we'll just say error. And the second is the level where the error occurred. And this uses the same level system as all the levels in the debug library. Sorry if you just heard my phone go off. So we don't need to go over that again. So we say 1, that means the function that called error is the level that we want. So if we save this and run it, the message pops up and it says error. I doubt you could see that, but that's what it said. So the next function is very simple. We're not even going to do an example for it. It's called getmetatable. So getmetatable, and this is kind of the opposite of setmetatable. You give this a table, we'll just say t, as a parameter, and it will return all the metatables, or all the meta fields or meta methods that table has. So right now t has none, so it would return nil. But if it had like the __ add meta method, then it would return that. So that's getmetatable. So the next function is called next, and this involves tables. So let's create a table. Let's create a simple one. Just has 1, 2, 3, and 4 with numeric indices. And then we'll say print next, and the parameters for next are the table, not t5, t, and then the index that you want to start at. So we'll say 2. And what next does is it returns the next index after the one you give as the parameter. So this should say 3 and 3. It'll return the index name and the value. So the key value pair. So save this, run, and we get 3, 3. We could call this at position 3, and it would give us 4. I don't know if I saved that. It'll give us 4, 4. And so on. And if you call this without a second parameter, oops, if you call it without a second parameter, then it will just return the first. And if you give it an index that's beyond the table, then it will return an error. The next function is called pcall. So to show this, we're going to create a new function, and we'll keep that. And we'll call it add, and it will take two parameters. Say n1, and n2. I don't like that space there. And the function is just going to return n1 plus n2. So now we can call pcall, or let's print it. So print pcall, yep, that's in lieu of 5.1. And the first argument is the function, and the second two infinite arguments are the parameters for the function. So we'll say 10 and 24. So what pcall does is it calls a protected version of the function. Not really a protected version, but it runs the function in protected mode. So pcall will return between two and infinite values. The first value it returns is true or false. It returns true if the function ran successfully, and false if it raised an error. And then the rest of the return values are all the return values from the function you called through pcall. So if we save this and run, we should get true and then 34. True, 34. But if we said error, and just have error here, then instead of raising this error and then just ending the program, it should return false, and then it returns the error message here. The next three functions have to do with metatables. So again, I'm not going to create an example because they're all pretty self-explanatory, and creating an example of metatables will take a long time. But I will show you the functions themselves so you can see the parameters. So the first one is raw equal, and you just get v1 and v2 as the parameters. The next is raw get, and you have table and index as the parameters. I'll obviously explain what these do in a minute. And then you have raw set, and this one takes table, index, and value for parameters. So what these functions do is they bypass the metatables of whatever table you're trying to get. So raw equal will check whether these two values are equal without invoking any metatables, and raw get will get a value in table at this index without invoking the underscore index meta method, and raw set will set this index value in this table to this value without invoking the underscore new index method. So these are just useful in situations where you want to bypass metatables and don't want to have to worry about deleting them and resetting them. The next function is called select, and this is a pretty useful function. And to show it, we're going to create a function called f, and it will take two parameters. Let's call it v1 and v2, and it will just return both of those values, v1 and v2. And end. And what the select function does is it allows you to pick which value you want to get from the function. So what you do is you say select, and then you call f for the first argument. Or no, the first argument is which return value you want to get. So we can say 2, and then we can call f. So if we save this, we need to actually give f parameters, so we'll just say 3 and 4. So what this should do when we call the function is it should just give us 4, and we'll print it so that we know. So print, oops, wrong file. Yep, we get 4, and if we put in 1, we get 3 and 4. And that is because the select function gives you all the return values from this index onward. I'm not sure what you would do if you... well, actually, no. What you would do if you only wanted to get the first argument is you would only set one variable. So what you could say is... you could say x equals select, and this x would only be assigned to the first value, and then you could say 2, and x would only be assigned to the second value. So that's just a function that allows you to pick which return value you get from a function. The next function is called toString. So you can probably guess what this does, but just in case. toString takes one argument, and it can be any type. It can be a number, or it can be a boolean, it can be anything. So let's just give it 1 for our example. And what this will do, oops, there it is. What this will do is it will just convert whatever the argument is to a string. So we put true in, then we get true. And you can't really see it from this, but from just printing it out, but it converts the argument into a string no matter what it is. So the next function is called toNumber, and it's very similar to toString. So you can probably guess that toNumber takes an argument that is a string, and it just has to be a string that's convertible to a number. So a string that is just a number. You can't convert letters to number. That's the string.byte function. So just have the string that can be converted into a number, and then the second optional argument is what base you want to use. So if you don't know what base means, it's like how you count. There's binary, which is 0 and 1, decimal, which is what we use in day-to-day life, 0 to 10, or 0 to 9, hexadecimal, 0 to F, so 16, and you can go from base 2, again binary, all the way up to base 36, which is 0 through 9, and then A through Z. So let's just have base 10 here. This is what it defaults to, so I really don't need to put that there. We hit save and run it. We get 67, and you can't really see it in the output, but the type of the value being printed is a number, not a string, even though we inputted it as a string. So the next function is called unpack, and I'm just going to show you how to use this function. I'm not actually going to create a real example with it, because it's a very self-explanatory function, but it would take a bit too long to actually create an example. So let's create a table that has, we'll say, 1, 2, 3, 4. Just has the elements 1, 2, 3, 4. And then we could say unpack t, and this function just returns all of the elements of this table as individual values, rather than a table. So again, I'm not going to create an example for that, because it would take a bit too long, and it's a pretty self-explanatory function. I'm sure you can figure out what you would use it for if you need to use it. So the last function is called type, and this is a pretty simple but very useful function. So we have type, and what this function does is it takes one parameter and it just returns a string that contains the type of that variable. So it will be like number, string, boolean, and so on, and I'll show you a bunch of different examples with everything it can be. So if we give it 1, a number, then we get number. If we give it a string, then it will say string. If we give it a boolean, we get boolean. I'm just doing this to show you the spelling and just exactly what it's outputting so you can use this. If we give it f, then we get function, and if we give it table t, then we get table. And out of curiosity, I've never tried this before. Let's say co equals co. See if I still remember to spell this. Coroutine dot create, and I think we give it co, and then we'll say function x equals nil. And doesn't matter what we put here. I'm just trying to see what happens if we give it a coroutine as an argument. So let's say co. I think that's a valid declaration of a coroutine. Can't remember. we get an error. So that is not valid. 1 sec. Right, so coroutine.create is the one coroutine function that you don't pass the coroutine variable into. So now it should work. Thread. So I guess coroutines are considered a thread by this function, which they kind of are. So that's the type function. So that's all the functions we have to go over. Oh, and one more thing. Just underscore and in all caps version is just a string that contains the current version of Lua you're using. So you see I have 5.1. But that is all the functions and variables we have to go over that are predefined in Lua. And now, by request from a viewer, I'm going to go over multidimensional tables because I never went over them and I definitely should have, so here we go. So if you're familiar with any other programming language, this shouldn't be too hard for you. You've probably already learned about multidimensional arrays there. But if you're not familiar with any other programming language, then this could be a difficult concept for you. It definitely was for me. But once you understand it, it's very easy to use and very useful. So the main thing that will help you understand multidimensional tables is understanding that it's not really a feature of the language. There's no special syntax that allows you to create a two-dimensional or three-dimensional table. What you're doing by creating when you create a multidimensional table is you're creating a table that contains tables that contains values. So I'll show you. We can create a table here and just indent it, and that table will contain some more tables. This is actually kind of unclean. So our table T will contain the table 1, 2, 3, and it'll just have 3 values in it. And then it can have another value. We'll say 4, 5, 6. And then it can have another table value. 7, not 7m, 7, 8, and 9. And let's just pull this back up to this line. So what we've done here is we've created a table called T, and it stores a bunch of anonymous tables that store number values. So this is a multidimensional table. I haven't used any special functions or commands to declare this as a multidimensional table. It's just a normal table that happens to store tables, and that makes it two-dimensional. So therefore, if we want to access a value from our table, what we say is print T, and we say T at position, we'll say 2, so we want to access this table in T. So T at position 2, nope, that's wrong. T at position 2, and then you have another set of square brackets right next to it, and let's access the 6 in this table, so at position 3. So what we're saying here is we want to access T at position 2, so this is 1, this is 2, so we want it to be in this row, and then we're saying 3, so we want it to be in this column, so 6. It's very similar to matrices in math, so you can think of it like that. And it's not XY, it's YX, if you want to think of it like a coordinate grid, so you go down on Y first, and then across on X second, and that's how you access the values in your table. So just to prove to you that I'm not lying, we get 6. And we can access any value in the table. We can say 1, 3, we get 3, we can say 3, 2, and we get 8. So you can access any value within the table like this, and you may think that you would use something like this to do it, so this would be row 3 and column 2. And the only programming language that I know that does this is C#. C# does actually have a separate feature in their language for multidimensional arrays, but most languages don't use this. You just use an array of arrays, or in this case, a table of tables, which is pretty much the same thing. So hopefully you understand this. If you don't, just tell me in the comments. I will help you with whatever you don't understand. And that's all for this tutorial. And in the next tutorial, we'll finally be getting on to the C library. So the next tutorial will just be how to install Visual Studio, how to install... actually, no, that's all you need to install, and how to set up Lua with Visual Studio. So look forward to that in the next tutorial.